You're welcome. This is Shedo's Academy, the house of Shedo. This is a place where we bring understanding to concepts in mathematics and physics. And for today, we are looking at Math 121, a very important course for our first year students in the University of Nigeria and in some couple other universities in Nigeria. And as you can see, these are the outlines of the various topics under Math 121. We have function, limits, and continuity of a function, differentiation, the application of differentiation, integration, and the application of integration. Today, we are going to be looking at function, but the way we are going to be doing this is we may not necessarily begin to go into the various depths of the concept of function. We will pick certain concepts under function and then see how to bring understanding to that concept in relation to problem solving, which is very, very important. Okay, so this is the concept of function, and today we are going to be specifically talking about the domain and the range, and then we are going to look at exam questions that is under domain and range. But then what is a function? What actually is a function? A function in mathematics is simply a rule. This means that it is a rule that relates the values of a variable x to the values of a variable y. So if you have a particular rule that can produce values of y for every given values of x, that rule is what we refer to as function in mathematics. Now, the rule can be written more in form of an equation or in other terms in mathematics. But what is so important here is that if you have certain set of values for x, let us say you have values like this, 2, 3, and minus 1. We can call these elements of this set what? X. And in the language of function, we call this particular set the domain. The domain simply means the input values for this particular rule. And when these values are imputed into this particular rule, we will now have another set of value. For example, let's say 6, 0, and 3. Now, the relationship between how these values produce these output values is what we refer to as the function. So in the language of mathematics, we can call this the domain of the function, while we can call this the codomain of the function, which all the values can now be seen as the range of the function. Like for example, if I have y is equals to 2x, this is a function. Why is it a function? Because for every value of the variable x, which is the domain, this is an independent variable. For every value of the variable x, I will definitely obtain a value for the variable y. So let's use these values here. 2, let's substitute the value of 2. We have 4. Let's change this to 4 to make it more realistic. Let's substitute the value of 3. We have 6. Let's change this to 6. Let's substitute the value of minus 1. We have minus 2. So what do we have? We have the set of values which together we call the set X, which is the domain of this particular what? Function. And then when we introduce the domain into the function, it gave us an output of 4, 6, and minus 2, which the numbers togetherly can be called the range of this particular function. So this is the idea of what a function actually means. It is a rule in math that shows how one variable depends on another variable. We can call this the independent variable. Then we can call this the dependent variable, because you cannot obtain the value of y if you don't have the value of what? X. So the nature and the value of x actually determines the value of y. That is very important for you to know, that the nature of the values of x is what is responsible for the nature of the values of y. So one more thing I would like to say is this, is that in representation, because math deals a lot with representation, we have various ways we can represent or express our function. I think the most popular ways, y is fx. You can have y is gx. You can have y is hx. All these are just representation. They are all the same thing. This is a function of x. This is also a function of x, and also a function of x. So f, g, and h are just letters that are used to represent function. You can use other letters. There is this freedom in mathematics to choose letters in making representation. The only thing is that for math 121, I think it is more conventional for us to use f, g, and h, and maybe a few other representation. So let's see the domain of a function. Now look at this question. The domain of the function. We have function fx, the square root of 1 over x plus 2. So these are the options. Which of these options represents the domain of this function? Remember we said, based on the concept of function, that the values of the independent variable, that is the values of x, since this is the function of x, is actually what we call the domain of the function. Why this fx itself is the function, which is we can call function y if we like. Now, I said earlier on during the concept of function that if we have a function y is equals to fx, that the nature of the values of x is what determines the nature of the values of what? Of y. So looking at this particular function, you see that this is a rational function having numerator and denominator. And we know in mathematics that for a fact that no rational function have a denominator of what? Of 0. No rational function. It is not defined. That is, if the denominator of a rational function is 0, that function is not a mathematical number. For example, 1 over 0 is not a mathematical number. We cannot place it within the number line. It is not defined. So because of that, we begin to see that for this function to actually, for the values of this function to actually be obtained, then our denominator x plus 2 must be values that are greater than what? Than 0. And if this is so, we know that x will definitely be greater than minus what? 2, from x plus 2 greater than what? 0. So what do we have here? We have here that the values of the domain, which is x, must be values that are greater than minus what? 2. So we can have minus 1, minus 1, 0, 1, 2, 3, 4, 5, all the positive numbers on the number line. So I will now say, using our set notation, I can now write minus 2. Now this particular notation simply means that I am considering numbers that are greater than minus what? 2. So I have here minus 2, and then I can have here my infinity. So this simply means because of this set bracket notation I'm using, so this means that the domain are all numbers that are greater than minus 2 and runs down to infinity. So what is so important here is to understand the kind of function you are dealing with. Now, when it comes to rational function, it's good to always test the idea that no rational function should have a denominator of what? Of 0. And also important is to know that if this is a square root function, then we know in mathematics that there is no roots for a negative number within the real number line. There is no root for a negative what? Number. So I cannot say that x plus 2 is less than 0. If I say x plus 2 is the denominator is less than 0, that means I am going into the domain of negative numbers, and there is definitely no roots for a negative number within the real number set. So the correct answer for this is definitely our answer B. So we're looking at the range of a function. Now let's look at this question. The range of the function, this is the function, y equal to 4 plus 1 over x. So it's a function of x. Now when we are asked to find the range, remember we said under the introduction of the concept of function that the set of values of y, which is the output values, represent the range. So we are actually looking for the values of what? Of y. So how are we going to do this? Now the trick behind this is when you look at this, you see that y is the subject of formula here. Of course, is the function which is dependent on what? On x. So the trick behind this is the first thing you need to do is to rewrite this equation and make the independent variable, which is x, the subject of what? Of formula. Okay. And when we do that, we have this is y equals to 4 plus 1 over x. We can bring terms, take terms to the other side of the equation. We should have 1 over x is y minus 4. Do you get that? And when we have this, we can call y minus 4 over 1. And if we take the inverse of these two equations, or if you like, you cross multiply, bringing your y minus 4 to this place and bringing your x to this other place, you should have 1 over y minus 4 equal to x over 1. So at the end of the day, we should be having x equal to 1 over y minus 4. So what have we done? We have successfully made x the independent variable. The reason for this is because we want to understand what we make this particular function true, what values is going to make this particular function true, and it is easier to get in this slide since we are interested in the values of y, which is the range. So looking at the nature of the function that you have, so don't forget this, that when you are dealing with function, what is so important is the nature of the function that you have. It determines every other thing. So looking at the nature of this function, we have 1 over y minus 4. This is a rational function. It has the numerator and it has the what? Denominator. I remember the fact once again that no rational function have a value of 0 at the denominator because it will be undefined within the real number line. So that simply means that y minus 4 cannot be equal to what? 0. It cannot be equal to 0. Y minus 4 cannot be equal to 0, of course. So for y minus 4 to be not equal to 0, it simply means that the value of y can take any other values within the real number line except 4. Except what? 4. Because if you substitute 4 here, 4 minus 4 is definitely going to give you what? 0. So the picture here is that we are considering that every other value within the real number line is applicable to this particular function except the value what? 4. So let's look at our options. Now what do we have here? We have minus infinity ranging to 4. Remember, because of this set bracket notation, this 4 is not captured. So this simply means from minus infinity to what? To 3. 4 is not captured. This is excluding what? Excluding 4. This is less than 4. And this is union. So let's consider the union. We have 4 to infinity. So remember, because of this set notation, this curve set notation, this 4 is also not captured. So we are looking at values that are greater than 4, which is from 5 up to what? Infinity. So this 4 is excluded here, and this 4 is also excluded here. But every other number within minus infinity to infinity is acceptable. So this should be the right answer because it captures every other number excluding what? The number 4. Because the number 4 will make the function to be undefined. This, especially looking at it from the way we have written the function in this form. So our range is our option A. The nature of the function is very, very important.